Welcome to the Stackin Sats podcast presented by Force-Based Mining. I am your host, Plamenko. Today I'll be speaking with Juergen Nittner, ASIC repair specialist. In this episode, we discuss Juergen's introduction to ASIC repair, the standardization of ASIC repair, basic component repairs, and much more. As always, this is not financial advice. Please enjoy my conversation with Juergen Nittner. I'm super appreciative to have you here today at the Force-Based Mining studio. This is the Stackin Sats podcast, and today I have Juergen Nittner here. Like I mentioned, very appreciative to have you here. And you are in the industry a whiz when it comes to fixing ASICs. In my opinion, you're also a savage when it comes to your social media, and I think it's a good combination. I want to give you a minute here, Juergen, to introduce yourself and kind of, explain who you are in the industry.
Okay, well, I'm Juergen Nittner, and I graduated from Purdue with a tech degree. That's a specific degree in maintenance. And then I moved to ASIC Master in Chicago. They trained me to work on the miner. And after that, I picked up, that was Bitcoin. That was the Bitmain miners. Then I picked up more recently the What's miners.
Mm-hmm. What about your journey? How did you come about Bitcoin miners? Were you always tinkering with things, your whole life? How did you kind of get into this background?
I actually have always been tinkering in my life. My father was, he came to the States in 1962, and he was also a tech. Only at that time, it was vacuum tubes. The vacuum tubes, huge console vacuum tube radios. At that time, they were called Sabas or Sabas.
Mm.
And after that, he's always been an amateur radio operator, a ham. So ever since I can remember, I've always been down in his ham shack, tinkering with something electronic.
Mm.
Then I went to Purdue and got an associate degree in electronics. That may sound weird, but it took me 20 years to get my associate degree because of a horrible sleep disorder.
Oh my gosh.
But I'm a half glass full kind of guy. And to me, it was just a testament to never giving up.
No, that's beautiful.
Doing what it takes to see it through.
Mm-hmm. You have way more patience than I do. I mean, I tried to get my second degree and I was pretty much done after like a year and a half. I was like, no, this is going to take too long. Very, very impressed with the testament. That's no easy accomplishment right there. What about getting into Bitcoin? How did you go from, getting the tech degree, eventually getting into ASICs?
Oh, well, that's directly linked to my sleep disorder. In somewhere around 2012, I got a proper diagnosis, and then also found out there was a new drug on the market. Well, maybe not too new, but new enough that it was. I remember my first prescription, which was covered by insurance, was like the bottle was labeled $1,000. And then I'd fall off insurance and be SOL. So I found out there was a supply of this medicine coming from India. And there was also discounts if you purchased it in Bitcoin. So my first Bitcoin was purchased, and I used it to get the sleep medication I needed to to go back finally and finish my college degree, which is what I did in 2013. I got back into school, had an amazing NASA internship at that time also.
Did you say NASA?
NASA internship, yeah.
Wow.
The zinc in the program, it was a robotics program out in Maryland. And the board they gave us to learn on, to play with, was the very first zinc demonstrator. The same zinc chip in all the Antminer control boards. So I can actually program one of those control boards. Not the S19. They've pulled out all the stops with that and enabled what could be called a DRM block. So it can only be an S19. Some of the other outfits have found workarounds to make control boards S17 and earlier run their custom firmwares. And they're even coming out now for the S19.
So is that how you had come across ASICs? Was working with this zinc?
I digress, but just
a little fun fact, yeah.
It's kind of a demonstration of how my mind works from point A to the point Z. Oh, back to point B. Sorry about the detour. But yeah, so I bought my first Bitcoin from a guy to get my medicine during a period where my insurance had lapsed. And then I realized there's something to this Bitcoin. It's really quite cool. At that early time, I bought some block eruptors. That's what they were called. Little USB sticks you'd plug into your computer and it would mine Bitcoin. It had one ASIC on them. It was the very first ASIC. The one you'll find, I think in the S5, S5, S7, something like that. Really, really early chip. Runs cool enough and a little wattage enough to operate off the power from coming from the USB port. Bought a couple of those. And at that point, I was hooked. And then when Bitcoin really, really got serious in 2016, I took the leap and paid way more money than I should have for an S9, which quickly took a turn to the south. And that's when I started to learn how to fix them. And I worked on that for a very long time, never quite putting it all together, never quite being able to call my repair efforts a success.
So were you able to diagnose the S9?
Yeah, I was able to diagnose it. What I lacked was the idea of what we call diode resistance, but is actually voltage drop. This is another thing that's taught from the Chinese courses, but it's really when you put two pieces of silicone junction together, a silicone junction, they don't have a resistance per se, but they do have. It's a voltage drop. So when you put your meter in voltage mode or diode mode, it's a V. Some people wonder, if we're measuring diode resistance, why is it a V? Because in fact, you're measuring a voltage drop. So that technique of being able to take the bad chip out, put the new chip in, and being able to check your work before even plugging it back in and waiting for it to boot up and doing all this right there while you're at your workstation, you'll know if you did something wrong. Mm-hmm. And once you've got those values in line with everywhere else on the board, chances are you plug it in, it's going to work. And I would have to say that's the key point that I was always missing. It was always working on it hard and long, and plugging in just to find it doesn't work. And at that point, it's like, come back to it in another month. I'm defeated, but I'm never out. Down but never out. And that took me all the way to this year, when I, on a hunch, looked to see if there were anybody doing ASIC repair in the area, and I found a place that just happened that it had only been open for 2 months. So I started working there the third month it was open, I think. And that was a year ago. And Austin, my teacher, taught me everything I needed to get going. And it was all history from there.
And this was at ASIC Master?
That was ASIC. That is at ASIC Master, yeah.
So what was it with your, experience with Austin that, what information did he have that was able to kind of just make all that click for you, in that first moment?
Well, it's one thing having the manual and having them talk about the diode resistances. But having Austin to teach you its true significance as part of the repair process, as part of a successful repair process, that was what he taught me. Almost. Well, it was definitely within the first week, and it really my skill really took off from there. I think by back then we were working on L3s and S9s, and by June or July we were moving on to S17s and S19s. Their architecture is very similar, even though their hash boards are shaped differently.
So the progression of working on something like an L3 and moving on to like a 17 series, was that just the different contracts you guys were getting, or is that kind of just like as these newer machines, were running longer, then they started being the ones that were going to need the repair, the maintenance for? I guess that's always where I'm curious, how does it go from working on this machine to working on that machine?
Well, ideally, you're going to be skilled in the machines that have just left the warranty period. Those are going to be your most profitable repairs, because they're still they're going to have the highest value still. They're going to have the highest intrinsic value that can justify the cost of a repair. And to a repair shop pricing their repair, pricing their repair jobs or their repair estimates, it's obvious that's where you want to be able to repair. And up until early last year, S9s were still profitable.
Yeah.
But that quickly changed. And so too did I switch to looking at S17s, which are in some way still profitable today. If you can get the cost low enough.
Yeah.
I think you need probably, I see 8 cents a kilowatt is the common number, but for an S17, you're probably going to need 6.
You might even,
but some people
might even need lower.
Might even need lower, but some people can find those. Some people have that. All of the some miners are really ingenious, like the flue gas miners.
Flue gas miners?
Yes, the in a mining or in the oil mining industry, when you're pumping oil out,
gotcha.
You have all that gas escaping. You're not doing anything with. You're burning it off. But if you could set up a generator there, and you bring out a shipping container full of mining units, once you've reached your ROI, you're basically your price per kilowatt hour is 0.
Yeah, so it's not that, you'll hear people using like the flare gas and they'll say it's like free energy, but it's just basically getting it down to like the closest amount of 0.
You got to get to your ROI, but so that's where the real whiz and the real calculations come in. If you can figure out how to get there quick for the lowest cost, your success is going to be guaranteed.
Yeah, I mean that's a great example where something like an S9 will almost be, there's no limit where it's not profitable if your energy is free. I know this happens a lot in South America. I've worked with a lot of people from Latin America and the areas around there, and they'll have very cheap, hydro energy almost to the point where it's free. And they're all about S9s, 17 series. So it's cool that there's always a place for that. But when you're looking at like, someone like these larger pubco companies, or you're looking at people who are, trying to get into mining, it's going to be about the newest gen models. And I find that that's where the repair becomes, that much more important because it's that much more skilled. And I'm curious, what's your opinion on working with like newer gen? Have you worked with like 19 series before for ant miners?
Yeah. Well, the big thing when you go from one generation to the next, it's board by board, machine revision by machine revision. Sure, the S15, the S19 and the S15 are quite different. But even within the model series, there's enough difference that you need to know what you're doing. The S, to use an example of, let's take the S17 Pro versus the S17 Plus. Their hash boards are wildly different, just based on their density of chips. So it takes some time to build skill on a series, and additional time for each submodel.
Mm-hmm.
Just to illustrate that point even further, the S19 series wildly changed technologies, beginning with the S19J Pro aluminum. They were all multi-layer PCBs at that up to that point. And now there's single-sided PCB bonded to a piece of aluminum. Exactly what WhatsMiner has been doing for many, many years, with quite a bit of success.
Mm. What makes those so much more successful?
The
aluminum.
They have two factors that keep them just keep them going. One is the fact that they're aluminum. They dissipate the heat very well. The chips are kept very comfortable their entire run life. The other one is switching to a single-sided PCB, single-sided circuit, reduces your complexity. And whenever you reduce complexity, you always get an advantage in robustness, in durability.
Right.
The more things that have the opportunity to fail, the more chance they will.
And when you're dealing with something like an ASIC, and your ROI can change significantly depending on the price of the Bitcoin. You're dealing with energy changes, price for that. You need these things running 24/7, and you have to have a way to be able to maintain that. And that, goes beyond just the machine itself. Then you're talking about, how you're running it, what type of facility, contents in the air, things like that. But it seems like you're saying, with the aluminum board, that was just such a game changer to be able to look at these things, more durable for that 24/7 operating.
Yeah, well, the failure rates for those multi-layered PCBs, think of a unit. It's two things. It's the compute unit and the power supply. So the failure ratios to everything with a multi-layer PCB was probably 10-1. 10 hash boards fail, and maybe you get one power supply that needs to be replaced. But now it's exactly the opposite. You're replacing 10 power supplies for every board you're fixing. And power supplies are extremely easy to replace in the field.
Mm.
So you're saving on so many levels. It really is a game changer. You no longer have to send units out as a whole, incur all that shipping cost. You can just replace power supply. And that's what a lot of people are doing now. So that is improved uptime overnight.
Mm-hmm. But you're still getting, instances where chip level repair is necessary.
Yeah, there'll always be for whatever reason, maybe could be manufacturing defect, just an imperfection in the solder connection that was used. Something that I see having a background and a technical degree is I can understand why something has failed. I think all these certification courses, they're teaching people how to discover what has failed. They don't really go over why did it fail. It's more of find and replace, whereas I can determine how something has failed on a new technology that doesn't require me to go get certified for that machine, which is probably just a regurgitation of what was taught in the last class.
So I feel like there's a couple good points to mention there. One is when you're dealing with, ASIC repairs, you're dealing with ASICs in general, you're dealing with Chinese manufacturing, and then you're dealing with these like Chinese repair courses. So a lot of things are going to get lost in translation. And then, minor repair for me is obviously something that's on my mind when you're brokering ASICs, when you're working with facilities that run large amounts of them. Repairs are going to be needed, and it's going to be something that you need to have a way to tackle. So for me, it's almost like once I started digging into the research of, what it means to work on PCB boards and just in general to be doing these sorts of repairs, you need to have a lot of education and experience. And that's one of the things that makes me wary about seeing all these companies, talk that they can repair. We can repair, bring it in, whatever it is, we'll take care of it. You hear people say chip level repair. You hear all these buzzwords, but I think you're just tapping into a really important point that it is a very, unnavigated territory. And I don't see many people who are coming from a background of fixing electronics, going into ASIC repairs. Maybe I could be wrong, but that's kind of been like my experience from it. And, as someone who fixes ASICs, I want to ask you, like, are there that many people who can repair ASICs out there as are advertised?
I'm sure you could rustle up a dozen.
A dozen?
Yeah. Across all of the fine organizations in the U.S. doing repair. Obviously, they're going to be the lead. So there's several successful organizations doing repairs because they at least they have one of those highly skilled technicians who've either through experience been in it so many years that they're an expert, or there may be a handful who have had a technical background to learn the differences of this new technology, and almost overnight be an expert too. Sometimes when I'm learning the quirks. It's always about the quirks of a new submodel. What has been changed? What are the advantages and what are the disadvantages to each submodel? I don't consider myself an expert unless I've spent 2 or 3 days on one single hash board.
What do you mean by that?
It takes...
Like I got you now. Like you're saying, until you can get to that point where you're fixing a board, 2 to 3 days.
Now, until you've built the amount of familiarity you can in 3 days with one board, you're not really an expert. That is to say, spend 3 days on a board, and I will agree, you probably know it pretty good. You know what's different about it. You know what's the same. And that allows you to skip so many steps and jump from problem to solution very rapidly.
And that's all. Oh, go ahead.
And not only jump from problem to solution very rapidly, to hit that target with the highest possible success rate. Mm. You saw on my LinkedIn page where I pulled, they all came from one unit. They were not cherry picked. They were all not functioning. I didn't quite tell the truth. One of them had 33 ASIC. They weren't all zeros.
They weren't all zeros? Oh my God.
But they were all non-functional. 3 from one machine and another one from a second.
And what were the submodels of the machine?
Those were S17 pluses.
Okay.
And I was able to identify not what was wrong, but I was able to identify what went wrong. And from knowing that, I was able to take the steps necessary to achieve a 100% success rate in repair. And I did not have to turn on my hot air station at all.
Wow.
The process I went through, skip that step entirely, because it actually, using a hot air gun can sometimes cause almost as many problems as it fixes. And this uses something entirely different.
So this is when you're talking about hot air, you're talking about like doing soldering on the board? Yeah,
a little hot air gun you bring down to the chip. Mm. Well, it also heats the chips up around it. Mm-hmm. And they start expanding and contracting. Now they start going bad.
Yeah, and once you really kind of get a feel for the nuances of all that, you can see why, ASICs are such a fickle thing, and why, you really need to trust the person who's doing the repairing, and trust that they, like you said, it's almost like in my opinion, it's almost like a car repairman in a lot of ways. You need to trust the person who spent X amount of hours doing this. They don't need a manual of some sorts. It's almost just become like second nature for them. Like you're saying, to go down the checklist in your head, not to be looking for what's the issue, but to be able to diagnose what went wrong or what exactly am I searching for.
Right. I was telling you about the diode resistance or the voltage drop in a diode. That is an extremely useful tool for a learner. I never do it anymore. I don't need to. But it's an important check. It's an important check phase when you're learning.
And that's when you're going and you're touching the points and you're reading the voltage for those diodes, correct?
Yes. Yeah. Well, a diode is the simplest form of semiconductor, and that's just two pieces of semiconductor together. And when you're looking at a fully integrated ASIC, well, that's just all kinds of silicon put together in all different ways. Thousands of millions, billions of transistors. Well, it also allows you a way to check to make sure that you have soldered it on correctly, because you can measure their values on one side of the chip, and they need to match a certain value on the other side of the chip,
right,
in order for you to claim that you've placed it properly. And once you've placed hundreds of them, like I have, you can know at a glance almost instantly whether you've put it on right.
Yeah, and I will attest to this. I've seen you do it. I mean, I've seen you just pick it up, put it up to your face, and where I see others needing microscopes to tell me what's going on there.
That's actually a very interesting. It's like the only advantage to me being terribly blind. I have like -8 prescription, and that is a crazy macro vision.
So you got magnifying glasses, is what you're saying?
No, without my glasses on, I can see incredibly small things. Incredibly small, and a lot of times that's what I'm doing when I'm soldering. I have these clip-on magnifiers that are handy, but most of the time I'm just soldering with my macro vision.
But yeah, I like
maybe other people do need the microscope. I shouldn't discriminate like that. I shouldn't discriminate against the well-sighted.
No, I feel like when you have your magnifying, like your glasses on, you have them in I think it's like in your Telegram photo or LinkedIn or something. And that's Maestro Juergen, as I like to call it.
Yeah, those. I used to have the watchmaker kind, the big plastic ones. And then when I went up to Canada to train some people on S19J Pro aluminum, they had these kind that you would slip on over your glasses. They could slip on over glasses. They still had the earpiece. They had a light on them, and they were heavy. And I found out that you could go even simpler, and just little clip on 2 lenses, and I never went back. Never touched a magnifier. Never touched a microscope again, except to make videos.
Yeah, I was just about to say, I'm pretty sure I saw you with a microscope in a LinkedIn video.
Yeah. On my LinkedIn or my YouTube channel, ASIC X.
ASIC X on YouTube. Very cool. So I kind of wanted to circle back a bit because we were starting to touch into it. You mentioned that, a lot of these people who are kind of more advanced in their knowledge of repairing ASICs, they had learned, from like an Antminer repair course, or had learned from, someone who is Chinese attempting to translate, into English. What are some like the issues with that? Is it like a standardization that just doesn't come across when they are, designing these English-based courses?
Well, that's if you a lot of the techs that are top of the field, they didn't have to deal with that too much because they benefited from the experience of going to the factory. This was all pre-pandemic. They got to go to the factory. They got hands-on. They weren't taught from well, to some degree they were taught from the manual, but on top of the manual, they were able to glean the experience from multiple people. They're doing it every day.
This is something that was pretty common, you said, pre-pandemic?
It was all pre-pandemic. If you wanted ASIC training, you went to Shenzhen. You flew out, and they would train you. After, maybe sometime before, they started to roll out classes in the U.S. to some of their bigger sites, bigger customers, and they would be taught from materials and vetted teachers certain keywords that really weren't the right keywords. Austin taught me about improperly soldering an ASIC, and this is the product of not using enough heat. He would call it pseudo solder, and for a long time I was trying to figure out what exactly he was talking about. What it was a couple days later that I realized somebody was teaching certified techs that what we call a cold solder is pseudo solder. But they're the same thing. Same thing. Nobody except ASIC repair technician would know what a pseudo solder is. It was kind of invented just for our industry. I'd be always curious on how it came about, but that became the convention.
Most likely some kind of Google Translate lost in transition.
Yeah, probably it.
How do you feel about these courses? There's a lot of repair courses out there. A lot of them promise you that if you take this, you'll learn how to repair an ASIC. Are there any good ones out there, or do you have any strong feelings one way or the other?
Until I started developing my own class a few months ago, they're all derived from the same Bitmain teachings, or now there's other companies doing certifications that I haven't had much experience with. But they all kind of follow the same guidelines, many of the same PowerPoint slides, all that sort of thing. They will give you a good background in the they'll give you a good background in the theory. And they will introduce to you several techniques to isolate problems. And after that, steps to take to repair that problem. And so basically, you come from a week-long certification with a huge box of little tiny tools, all just kind of mixed together. And it's up to you to remember which tool you have to pull out to get the job done. If you are lucky enough to find some place with a 2-week certification, by the end of that 2 weeks, you are basically able to use those tools by memory. So the first week is a good intro. You're taught how to find the problem and how to fix the problem. But in the second week, you are taught different ways to find different problems and which repair methods work for which specific problems. There are many different kind of components on a hash board that can go bad. Primarily, one is called an LDO. It's a little tiny voltage regulator. One of my sayings when I started doing repair was, "It's never the LDO." I've been proven wrong, maybe 4 times. A lot of the time, it's a bad solder repair job, and you've just grounded out something somewhere else. So it's a little voltage regulator. It's a little power supply, but somewhere you've messed up the circuit, the circuit flow.
And what is like a bad solder job? What does that do to?
Oh, generally your LDOs can put out up 0.8 volts or 1.8 volts. Now, even you'll find 1.2 volts. But if you have a bad solder job, generally you're gonna bridge to ground. So you're gonna probe that LDO, and it's going to be 0. Or you're going to slightly ground it out, and it's just going to be a really low number. But it's not the LDO. And sometimes it might be, but usually not.
What are
a lot of
Go ahead.
There's a lot of unnecessary LDO replacements.
That's interesting. I've had some personal experience, and with the person who I was working with, that was like their theory every time. Oh, it's the LDO. It's the voltage regulator. It's definitely, we got to get a new one. And, it's not so easy to source all of these components either. So if you think it's that, much of an issue for that little component, then, well, now we got to go find it.
If you look at an LDO, it looks like a very simple little thing. Something you might imagine goes out very easily. But in fact, they're quite sophisticated. They have built-in overcurrent protection. They have built-in short circuit protection. They have they have built-in thermal protection. They have all these protections built in to keep them from blowing up. Sometimes they blow up still. So they're actually quite a lot more robust than people might be led to believe. And that's the foundation of my saying it's never the LDO. Something's catastrophic has happened if your LDO turns to smoke when you plug your board in, because it wasn't the LDO. Something else around it caused that LDO to fail dramatically. And that's just the kind of thing that they don't teach in the certification classes.
Is that something more universal with like electronic board repair in general? Or is that just something that you kind of pick up from working on, a lot of ASICs and a lot of boards?
It kind of comes from a understanding of the underlying technologies and how they've evolved since the earliest microchips, since the earliest silicon devices. And how complex even the most simple thing is quite actually. I mean, these LDOs were created by teams of PhDs, so they're very advanced, very even for their size. The reason they're called LDOs is because the previous generation, LDO stands for low dropout, and then what goes without saying is voltage regulator. Low dropout voltage regulator. The previous generation, they called the 78,000 series. I mean, they call the 7800 series, like the 7805, is a 5-volt regulator. And because of the second law of thermodynamics, you can never have a 100% conversion rate between any kind of energy.
You'll lose some of it in the transfer.
You'll lose some of it. So the previous generation, you would have to go quite a bit higher you'd have to go quite a bit higher from your desired output to properly operate that voltage regulator. And then the subsequent technologies, that level became lower. The low dropout voltage regulators. So one of the things I look at when determining whether it is the LDO or not is I will look at the source coming into it. I will not just look at the output, but if it's meant to put 1.8 out, I will need to see that it's getting at least, 25 to 50% higher voltage into it. And that's just to be safe. And then a lot of times, and I'm not exactly sure, but all clock circuits seem to be run at less than a volt or 0.8 volts. And those are then directly run from the 1.8s. So its source is easy to find. If it doesn't work, if the 1.8 doesn't work, you can be pretty sure the 0.8 doesn't work either.
Mm-hmm.
So don't stop. If you start and you test the 0.8 and you're like, oh, doesn't work, let's replace it. Well, that wasn't the reason it wasn't working.
Mm.
You should have checked the 1.8. Next. Is it working? Oh, that's not working. Well, that's why the 0.8 wasn't working, not because it needed replaced. It's never the LDO.
What about some other components? Are there any other, more common issues you'll see with components on a board?
Semiconductor memories are somewhat temperature sensitive. They're also sensitive to cosmic rays. So if you have, on many hash boards currently, although that's changing as technology rapidly does, there's at least two places on a hash board where information is stored in memory. There's something called an EEPROM. And there's also a PIC chip from Microchip Corporation. And both of those have a little permanent memory storage in it. No, semi-permanent, rewritable. And if you heat that up too much, the bits may flip and it stops working. All your ones and zeros have to be all just the way you intend them. And also the PIC has a memory location that you can program to. It's a little tiny hard drive. So that's something that often goes wrong. Sometimes people will be heating a board up a lot and they'll be like, I knew what the issue was. I fixed the issue, but now it's not working. Well, take a moment and re-upload the data to those two chips. The heat you may have been adding to the board was high enough that it malfunctioned. So that's another.
When you say upload the data to them, is that what people refer to as flashing?
Yes.
Like flashing the EEPROM, flashing the PIC chip?
Yes. You would flash the PIC because it actually has flash memory. The EEPROM would be programmed because it has a different kind of memory, not a flash memory. And also the control board has its own memory that you can flash to because it is actually a flash memory chip. The EEPROM is such an old technology. It's pre-flash drive, flash memory technology. I think that's NAND technology, where they just line up a bunch of NAND gates and give them the ability to remember what state they're in. So that's a word that's used a lot in our technology. The NAND recovery, which isn't NAND recovery at all. NAND is old 80s, 70s, 80s technology. That's what the EEPROM uses, NAND memory technology. So you could NAND recovery the EEPROM, but the flash. You do flash the... No, forget all that. Erase all that. So much, there's so much technology. I think it's NAND. I think it's still a kind of NAND technology. So much. There's so much. So much.
It honestly is so much, and this is like a very common theme. I feel like that I run into in Bitcoin is that I think I have my head wrapped around something, and then all of a sudden, you step into like energy, or you step into repair, or you step into just like logistics and supply chain, and then you're just like in a whirlwind again. And I mean, the same goes obviously with repair, but it's fascinating listening to you talk about a lot of this, because a lot of this is technology that has been developed over decades and decades. And when I used to think of like an ASIC, before, I thought these are specific computer parts specifically for Bitcoin. And then it's not until you start to digest the information that you realize that, no, these are pretty standard components to it, which is why it is so, peculiar that there is very little of a standardization in our industry, in the repair industry. Do you see a standardization coming forth? Or do you still see this as it's very much the wild, wild west?
As technologies are very aware of the time-sensitive nature of getting their ASIC out and running, there's no time for standards. You get it going, you get it working, you get it out.
Yeah.
Something I noticed Bitmain did in the early days is there's some level of conjecture there, but I think it's accurate. There was some level of purchasing technologies and to this point, other than modify the technology to go to smaller processes, smaller nanometer processes, more efficient processes, which is largely the function of the fab you choose anyways, they're still using the IP, the intellectual property that they purchased for the... I don't know how far back it goes. For the S5, for the S7.
Wow.
Or maybe the S1, for all I know. And all they've done is up to the number of cores that you can put on a chip.
Mm-hmm.
When you're an ASIC designer, you have some very sophisticated software, and you have all these little pieces that you add like building blocks in the software, and each block is called an IP, an IP core, and you stack all these cores together, and you get something that actually does something. Well, a lot of time and money has been put into those cores that you can, well, I mean, if you're a PhD, that you can quite rapidly put together and make something that works with little effort. But you have to pay for these cores. If you want to write some code to a Zinc, if you buy a Zinc development board and you want to program it, do some things, there are some free libraries. There's some free cores that you can get from Xilinx. But if you are commercial you pay for those cores. You pay quite a lot, and you pay quite a pretty penny for those cores. So, I mean, it just makes sense. I think that in the new technology that Bitmain uses, they've gone from 1.8 volt data transmission technology to a 1.2 volt. And I suspect that was their investment in a new communications IP core.
So for layman's terms, what exactly is dropping that 0.6 volts? What's the amazement of that?
Well, it's more efficient.
More efficient. Mm-hmm.
If you can lower the voltage, you can lower the heat that you're losing, and lost heat is lost efficiency. So you definitely want lower. That's always been the core of the semiconductor industry. They started the old days, the dip chips, the big chip with the pins on two sides. Mm-hmm. Those were called TTL. Another term you'll hear a lot in these courses, because it just is it's another way of saying 5 volts, and 5 volts is the signals that used to come out of a serial port. A serial port is a way of sending text. So, but that technology has progressed. It's now a 3.3 volt signal. And with your little serial USB to serial device, you can then receive data from your Antminer or whatnot and display it on your screen for diagnostic purposes. It may not be TTL anymore, but they'll still, because it's not 5 volts, but they still call it TTL or serial or what's the other one? Just tip my tongue.
Is this the information that like your kernel log is reading to you?
Yes. The kernel log that you can pull up on the web page is identical in most ways to the display that you can get from these 3 pins on the control board. The TTL serial port. Oh, it's called serial port. TTL serial port. COM port. Known by many things for different reasons.
Do you think we're going to be able to keep up with the rat race? Like you said, there is no standardization because we just constantly need to keep building and keep moving forward. Will there be enough people to repair these machines? Will it be lucrative to do it? Will it be profitable for people to, keep going this route? Or are we kind of entering a place where you just need to keep buying the newest gen machines, to keep getting the best hash power?
It's not going to be indefinite. People who can see the writing on the wall are learning to fix power supplies now because the hashboard repair is diminishing. But volume, just sheer number of systems out there should keep anybody in training now flush with cash. It's only if training courses really proliferate that there might be some real competition in the market.
It seems like it's quite the endeavor. What would you say to someone who wants to get into repairing ASICs? You know, what's the Juergen advice?
And it's all dependent on their motivation. It's that's what it all rides on. Are they friends with somebody who owns a farm? Do they own a farm? Those are perfect instances where I would say, yeah, absolutely, do it, learn it. I will help. And if there are people who think they should learn it because crypto's the big thing, they think crypto machines, they're always going to need repaired. There's always going to be a upfield for them. Well, that's the elephant in the room. Nobody's really talking about. And that's the end of Bitcoin. And I have no idea when that will be. Because sometime a quantum computer will crack SHA-256. And that's when everybody's wallet is value zero.
Man. Dropping the mic here.
I don't know if I want to. You want to edit that out?
No, that's it's important. You know, these are the important things that we have to think about. Not everything is secure and solid and precise, and pragmatically, we're always going to keep developing and keep getting further. And why wouldn't there be a quantum computer that can go beyond our imagination?
Yeah, people talk. They talk about cryptography and SHA-256 as it would take a computer this many hundreds of thousands of years to break this key. Well, quantum machines are not computers. They're an entirely different thing. Well, they compute, but
on the level,
they're not what we consider a computer.
We can't comprehend.
Yeah, we can't comprehend how they make their calculations. I think I gleaned a little bit that a quantum computer is the embodiment of being able to have all solutions to a problem at the same time. They're weird. They're certainly weird. That's quantum. Spooky at a distance.
Yeah, like some, who was a Dr. Manhattan, right? Like on some metaphysical level where you can solve the problem.
That was a quote from Einstein.
Yeah?
Yeah.
Wow. What about...
That was one of his... Nobel Prizes, quantum computers. The other one was, I think there were more than two, maybe. That was solar panels, photovoltaic effect. And you'll hear people in certain fields, they'll be talking about crypto, and they'll be addressing it, and they'll talk about quantum strong crypto. So there's plenty of people developing crypto, the crypto of the future. I don't know what they're going to do with BTC, though. I don't know what they're going to do with that.
Sure. It's like with hacking, the more sophisticated hackers get with their computing, the more sophisticated the defense will get with it. So hopefully if there's going to be a quantum approach, that we'll have some sort of quantum solution, for BTC. What about, despite the fact that we've already, taken it to the point where, we can go beyond the technology of Bitcoin. What is it about Bitcoin itself for you that has you so intrigued by it?
Oh, I'm a technologist. I could tinker or fix it. I'm there. These hash boards need it. I need the TLC. And I'm more than willing. Happy as a clam working on a hash board or power supply, which will be the next thing, because the hash boards have gotten so robust that now the power supplies are stacking up, and they're going to need fixed. So learning that is going to be important. Learning no, I think that's probably the two things.
Yeah.
That'll be most important in the near future.
I got a question about what you're wearing over there. I know to the camera it might just look like some bling bling, but could you tell us a little bit about what you got around your neck, Juergen?
Oh yeah, well this is a silicone wafer of ASICs. This one I got while working at a GM plant that I found out years ago actually used to make silicone wafers for the automotive industry. So automotive ASICs. This has 5 ASICs on it because it's a test piece. There's an ASIC in each quadrant and one in the center. It's just a calibration piece, but it's real silicon. It's real patterns. And I guess that's the only reason it survived and didn't get cut up into real ASICs. Is it because it was a test article? But it's a real thing. Lithograph. I forget what the nanometer technology is. People are talking about the chips coming out now, 5 nanometer. This is probably, I don't even know, 100. It's old technology. That's why it was decommissioned. It was no longer profitable. Even at that time, the equipment wasn't capable of going smaller. So it was just all shut down. And this came from Kokomo, Indiana, where I participated in the 30,000 ventilator project. When COVID hit, the government put out a contract for 30,000 ventilators. Many companies said they could do it. GM had a idle, empty building in Kokomo. They said they could do it, and they're the only ones who did. Everyone else fell short. And so during the pandemic, I went down there to fix the ventilators, and in a dusty corner of the basement was this perfect piece of historical silicon.
And now you're giving it some life after its technological use.
Now it's got some real life in the spotlight.
Well, being a little bit mindful of our time here, and the first time I met you, you came up to the DLI warehouse, and we were having some issues with repair, fixing some boards, and you absolutely grilled us. Like you gave me such a humbling experience of education. And I remember I asked you then, because you had mentioned you would sometimes spend, 12, 14, 16 hours just repairing ASICs, working on boards. I remember asking you, how can you do that? And you said, this is my dream job. This is what I want to do. And when I'm doing something that I love, it doesn't matter what the sacrifices are. And I feel like, talking with you today, we really got to dive into more of that. Like you said, this is something that you eat, sleep, and breathe. And I'm really happy that I get to just sit here and try to, be able to grasp just the scale of knowledge that you have, for ASICs, for boards. And I'm very happy that we were able to get you on here. I hope that we can do it again sometime and we can get even more technical. And I just wanted to thank you for making it out here, Juergen, and, sharing your love and your expertise with us.
Yeah, I mean, it really is a dream job. People go out to the store, they buy puzzles to take home and solve. People bring me puzzles and pay me to solve them. It's exactly that simple. The puzzles have several magnitudes more working parts, but that just makes them more interesting. That makes them more worth it.
Yeah, and I'll be following you on, LinkedIn and Telegram for all your updates and all the mad scientist stuff that it is that you do.
All right. I'll be adding some new content on reflowing boards, and we don't use ovens. I tried a reflow oven, and for hash boards, it's completely inappropriate. They never designed a reflow oven to work with what amounts to a massive heatsink with a little board inside. Reflow ovens are for like boards.
Mm-hmm.
So I figured out the right way to do it, and I wasn't going to give it away, but that's how I got that 100% success rate on those 17 pluses. I did the reflow, and it wasn't with an oven. It wasn't with the oven. Wasn't with hot air. That's more that I'll be talking about. You can see that on LinkedIn and YouTube.
Awesome. Well, we'll make sure to throw your links up on the description, and definitely be on the lookout for it. And just wanted to thank you again one more time for coming on, Juergen. Really appreciate it.
Well, it was my pleasure. Any chance anybody has to talk about what they love, I'm sure they take the chance. That's all I did.
Definitely.
It was a blast.
Awesome. And we'll look forward to having you again.
We can go another hour if you like. You're busy?
I feel like, as we keep working on this, we'll be able to get more in depth, and you and I can have the 3-hour episode that everyone's longing for.
Yeah. I don't think modern psyches can handle that sort of attention span. I think that was those kind of attention spans are pre-iPhone. Yeah, I think hour. Sure, that'd be fine.
Sweet.